Today we'll be factoring trinomials where our a, the leading coefficient, is equal to 1. Just like in our last video, we can factor trinomials when the value is 1 by finding the numerical values that multiply to give you c value and add and subtract to give you the b value. So in our last video we used it to where a was not equal to 1 and we had to follow the rule that had us multiplying our a and c. In this case, anytime that we are multiplying a, which is a value of 1, times c, we're only going to have the product of c's value, which makes it a lot easier to deal with. Now most of the time you'll already have a leading coefficient that is 1, and sometimes you need to simplify or factor out a common factor, the GCF, in order to make our leading coefficient 1, if possible. You still have the calculator tip to help find out which are factor pairs of your value, and this will help you out in order finding out which ones add or subtract to equal our b value. So to go into a couple examples. Looking at example 1. We have an a value of 1, a b value of -3, and a c value of -10. If we were to do our a times c like we normally do, we're just left with what our c value is, which makes this a whole lot easier. Then we can find our factor pairs. You can use the calculator trick method. And then we add them together. In this case, 1 plus -10 is -9. And 2 plus -5 is a -3. Now the reason why I started with the right values, my larger values negative, is because any time that we have a negative b value and a negative c value, that means that our larger factors of each pair are going to be the negative. As you can see, both of our sums were negative. After this, we follow the same steps. We are going to break our b value into two separate components. So the x squared stays the same. Instead of -3x, we break it down into the 2 and -5. So we have the -2x, and we have the -5x. I'm sorry, that is a +2. As it's a +2, we need a +2. -5x, and then our -10. So yet again, we reverse the step from multiplying polynomials, where we broke down our middle factor. From here, we can group them together. Our first two terms to make a polynomial, or binomial, and the second two to make the second binomial, getting a little bit closer to our originals of multiplying polynomials. From here, we factor out the GCF. 1 would be the coefficient, so we don't need to do anything there, but we do have a common factor of x. If I factor out x, that's x squared divided by x, leaving x. And 2x divided by x cancels out the x's, leaving us the +2. So I did not go into detail of situations like this, but our goal is to get the parentheses to be the exact same value. In this case, our leading term is a +x. In order to get a +x in our second parentheses, we're going to have to factor out a negative. Now the GCF that they have is 5 as well. So I'm actually factoring out a -5. When I do this, this will be -5x divided by -5, leaving me the +x. And negative 10 divided by a negative 5 gives me a positive 2. So to clarify, I saw that in my first parentheses, my x was a positive x. So I wanted to make sure that my other parentheses also had the positive x, which meant that I had to factor out a negative. Now that these are the same, I can factor out the x plus 2, the parentheses x plus 2, now if I divide this by the parentheses x plus 2, I'm left with x. And for the second term, when I factor out the sum of x and 2, I'm left with a negative 5. Easy way to look at it. After this step, you show that the parentheses are exactly the same. You write it down once, and then you write what is left, our x and our negative 5. A couple more examples. Number 2 shows that they are all positive values. I have an a value of 1, a b value of 9, and a c value of 20. So in this case, a times c, yet again, is just our c value. Breaking it down into the factor pairs, and their sum ending up equal 21, 12, and then what we're looking for, our b value of 9. So the sum of our factor pairs, and we find the one we're looking for. So we follow the same steps. We break down our b value. This is now going to be a positive 4x. And a positive 5x. And we still have the plus 20 on the end. Now, it does not matter the order of which factor you put first, whether it's 4x or if you put the 5x first, it's still going to end up with the same parentheses in our steps. So just to show what I'm doing in this step where I add the parentheses, to show that I'm creating the binomials, I factor out the GCF. In this case, dividing each term by x, leaving me x plus 4. And in our second set of parentheses, I divide out by 5, the greatest common factor. In this case, I notice that my x was positive, so I can leave my value as positive. This leaves me with x plus 4. So either way, I would be left with the same with the parentheses, and then my next step will always have the same parentheses. Does not matter which term you were to write first. The math will come out the same. My parentheses are the same, so I can write them down, showing that I'm factoring it out. And then I leave what was behind after dividing by the sum of x and 4. The first term is left with x. And my second term is left with the positive 5. So if I would have switched these around, my x plus 5 would have been in first. That is the only difference. Now another example of whenever my c value is negative, or my product of a and c is negative, we have to look at our b value. In this case, it is positive. So I want my smaller values to be negative. This time, whenever I add them together, negative 1 plus 70 is a positive 69. Then I'm left with a positive 33. This leaves me with all positive sums. 9. And then what we are looking for, our 3. Yet again, if the b was negative, then I would just make my larger's value negatives. So I have my two values. I can write my x squared. I'll show what happens when you switch it around. This time I'm going to write my positive value, my larger number first. So that's 10x. Then my smaller value, the negative 7x. And I still have negative 70 at the end. I turn it into two binomials using parentheses. Factor out the GCF. My first one will just be an x, like it has been for all the other ones, leaving me x plus 10 and in my second parentheses, if I notice that this one is positive, I want to make my coefficient positive as well. That means I have to factor out a negative value, in this case being the negative 7. This leaves me with the x, and then negative 70 divided by negative 7 gives me a positive 10. A clue that you're doing your math right, your parentheses are exactly the same. That means you can go on to the next step of factoring out your sum of x and 10. If I were to divide each by the sum of x and 10, I am left with the x and the negative 7. And here I have my two binomials.